Welcome to my channel. My name is Nehemiah Wekesa. And guys, I'm doing this video because a lot of people have requested me to assist them. These ones on the Kaggle thing because it has been tough for many. I know some of you are fond of reporting me. The other times, some people, when we were doing the discussion, some people reported me that I was sharing the solutions on my GitHub and it was suspended, but I appealed and that the account was restored. And also, some people also back then reported me to the ALX official that I wasn't doing the right thing. But guys, please just consider this as a guidance. If you have any issues, just let me know let me know. I'll just pull down the video. But please don't report me because this channel assists other people apart from the ALX people. But so basically here we are trying to implement the recommender system, and the approach here we are using the hybrid approach, combining both the collaborative filtering and the content-based filtering method. So for the collaborative filtering, we are using this SVD plus for matrix vectorization, and then we're also using the KNN with means. This one is for neighborhood based, and also we are using the slope one. And so basically these methods are purely for collaborative, using using only user item iteration. And that's rating to make the prediction, because on the submission they'll want us to submit with the ratings, like with the ratings and the ID, and also for the content based filtering. Here we are using the genre. Is it genre? I'm not sure about the pronunciation, guys. Please let me know the correct pronunciation in the comment section. I don't know how you pronounce this one. It is genres. I don't know. So basically, this is the approach that we are going to use, and that we are going to use in this system. And I want to explain every code here so that you can have a basic overview of what we are going to do. First of all, this code, if you want to access the notebook, I'm going to share the link where you can download. I've uploaded on my basically on the portal, on our portal. So we have these codes here, and we have two versions. I've created here two versions. So for example, if you want to submit quickly for the sake of time, you can use this version here of this notebook called a recommender system with high R RMSE of 0. This one is, I think, a 0.8 0.81. But if you want like the optimized, like the hyperparameters are tuned, and you have a good um root mean squared error, you can use this movie recommender optimized, this version. That's going to take some time, but this one is going to give you the best result. But if you want to submit earlier, because I see by the time I'm doing the video it is a bit late, you only have around 18 hours. So you can use this recommender system. This one is going to take around 50 minutes to generate the dataset, the submission dataset. This ensure that you're using this recommender system. This one is going to give you a root mean squared of about 0.81. But if you want to have an optimized version, you can use the movie recommender optimized version, this one, the one that I'm going to explain here in a few. So to access the notebook, you can go to, let me open here, you can search for name tech. The name tag I'm pronouncing is name tag, but the spelling is NEHMTECH. But I know on the ALX students, I'll attach the link to that page. So when you go to this page, so the first one, before you access any course, you need to sign up first. So to sign up, you can go to this tab called my portal, and then you can Now when you go there to this my portal page, then you can log in with whichever username you wish. Let me use Google. Let me use Google. Then name Wekesa Nehemiah. Basically, I'm doing this because the code is a bit lengthy. I couldn't push it on GitHub, and also yeah, so I decided just to upload on my what on my Google Drive, and then I linked it on this page, this data science. There's this course called data science discussion here. If you don't find it, just search for data data science data science, and then it's going to give you the results, and then you can see we have here data science discussion here. And then otherwise you can as well use this released date newest, like to search based on this one, like to sort based on the release date being the newest. So when you click on this course, when you click on it, then when you click on it, then you are going to have this page where we have this course. Remember, this course I'm going to delete it soon because I'm using the content from this course involves the content from the ALX. So it's not right for me to upload their content on this site, but it is for demonstration, like to guide people. So if I want to access this course, like the content, like those data set, go to the start course, and then the next thing you do, perhaps on your case are these I don't know if this tab will be there. Perhaps it won't be there. So if you don't see this section here, what you do, click here, click on the curriculum. When you click on the curriculum, you'll see the movie recommender system. So just click on it, then open it, and then you can click here to download the project file. So when you click here, it's going to open the Google Drive, and then you can download the dataset. Once you download, extract now to any folder, and then open it with a notebook. Like you can open the project with notebook. I know you guys are familiar now how to open the notebook files, either on the system or on Anaconda or on VS Code. You are familiar. But if you have any issue, let me know in the comment section. So once you have the file, then let me try to explain in a few what these codes does, so that you can have a basic understanding of what we are doing here. So basically, first of all, we begin by importing this number. This number is for numerical operations. Then pandas, this is for data manipulation. Then TQDM, DM, this one is for progress bar, because when you are trying to generate like your data set, it's going to take some time, and basically to be sure that it is working in the background, and also perhaps to get some hopes. Sometimes when something is delaying and then you don't know what is happening behind the scenes, you are curious, you can easily give up. But if you have something like a progress bar to show like the progress on how the prediction generation dataset is taking place, or how your prediction are taking place, it gives you hope, and you can relax. So basically, I'm using this TQ TQDM. This one is for the progress bar, and then this one is for this module here, or this class here, is from the sklearn for text feature extraction, and then here we're importing from this surprise. But there, guys, if you're using this surprise on the system, like on your machine, on your computer, basically ensure that you have the Microsoft, the Microsoft Visual Studio, I think a Windows or a desktop build tools for it to work. Otherwise, it won't install this module. So ensure that, or another alternative is to just use it on Kaggle. So when you use on Kaggle, make sure that the first thing that you begin with is you begin with this code. Run this code. Like open this notebook. There's that tab when you go to the, let me see, Kaggle. Kaggle. When you go to Kaggle, and then when you click on the what on code, I think not code, and then here you can click here to create a new notebook here. When you click on the new notebook, then it's going to initialize your notebook with this code. So ensure that you first of all run this code so that you can track the files of your datasets in the Kaggle. Remember this now, these datasets are now on the they are already on the Kaggle. You don't need to. So it's going to provide you the path. So now here, instead of like using, you can see here we were using here the data because it is in the same directory and it is in the same machine. We are using it like a Fortran. We are just specifying the name. But now if you're using it on the Kaggle, make sure that you are doing what? Make sure that you are passing the entire path, like because it has given you the path. For example, if you want to have the train, you can copy this path and then you just paste it where the train underscore df variable is, and then you paste there. You can do the same to the movies and all that, so for it to work. Otherwise it won't work. And also the advantage of working with the Kaggle, like your memory won't be depleted when you're trying to train your model or maybe to generate predictions. So basically this is what you need to do. Basically, if you're using the surprise on your machine, ensure that you have the build tools from the Microsoft. Let me see. Is it disk? Okay, let me search for Microsoft Visual Studio. Visual Studio, and then in the Visual Studio, when you download the installer, you can also download is it desktop or a Windows setup tools. So for that package to run, by the way, if you try to install, it will give you like the suggestion on which modules to install. So, but I recommend to work on the Kaggle so that you may not have any issues. And then so basically here we are trying to load the dataset. We are now trying to load the dataset to the notebook, and basically I added the print statement here to show that it is loading, like to see some progress. When it is loading, once it's done, then it will go. By the way, if you can also add in another print statement to show that when it's done, it can print done and stuff here at the bottom. And then now here is to do what? This is to now here we're trying to create the instance. We were trying to create a reader instance or object, specifying the rating scale of 0.5 to 5.0, and also we are trying to load the training data into the surprise dataset here. Surprise dataset. And then the next thing here, we're trying to perform the hyperparameter tuning, so that because we have a big dataset in this project, so we shouldn't use the default values. So we are trying to update like to change the hyperparameters, and we are giving our values, and they are in a range. We are giving our our hyperparameters. We are giving values to our hyperparameters here. So um, and then here. Mhm, mhm. Also here we are trying to do what we are trying to create a grid search object to perform the cross validated grid search with this class here. And then we are trying to do what we are trying to fit the grid search object to the data here. Then this process is going to take some time on the hyperparameter tuning. It's going to take some time. And then once it is done, then we can do it. We can now train the model. So these are the codes to train the model. So I remember here we are not using the default. We are not using the default what? We're not using the default SVD because we have a large data set, and this SDB is much better. This SVD which is noted with PP. But then you can always find the documentation here. When you just get stuck on something, you can always find the documentation here. You can always find the documentation on the supplies module here, and learn more about what the package does, and also the hyperparameters and everything. But now, because we are trying to understand together, so this is SVDB++ from this surprise library, from the surprise library. Sorry. And then where were we? So here we are trying to train the model. We are trying to do it. We are trying to train the model, and here, with here we are using like the best parameters for the grid search, and then here. So basically here. With this one, we are trying to get like the best parameters found by the grid search, and then now also for this, we are using also we are specifying these hyperparameters as well on this KNN with means object when you try to create this object, and also we are trying to do what we are trying to slope one all the models. We are trying to use this as slope one, object or a class to ensure that all the models are fit to the full training set. Remember here we have a different data set for training and a different data set for testing. So for the training data set, we want to ensure that all the data sets are fitting. We fit to the training set with this module or this class, basically class. And then here we are trying to prepare the additional features, like to ensure that the modules work well, or maybe it is optimized to give us the best route that's going to give us the best the best value there, the root mean squared error. And then so basically here we fill n and value, though we don't have any non value, but on this movie database, but if it were there, this the command like to fill the null values. And also we are trying to create TF IDF matrix from the movie genres. Is it genres? And I don't know the correct pronunciation. Then we are trying to do it. We are trying to calculate the global mean rating. We're trying to calculate the global mean rating, and then also we try to calculate the user and movie the movie the user and a movie biases with with these uh, with these ones. And then yeah, so this is what this function is going to do. This ensemble predict function is going to so basically on this ensemble function predict, so basically this, I think you've understood up to this point. Basically in a nutshell, what this one does, we have first of all this one is to remove the null values. In the event we have the null values, and then we are also trying to create what the t TFID matrix from the movie genres. Remember, the system is collaborative and also content based. So we are using these genres for content based, and then we are trying to do what we are trying to calculate the global mean, and then we are also trying to calculate the user and movie biases. And then now on this ensemble function, we've created here the ensemble function. So basically this function combines prediction from all the models and additional features. Remember, we have several more, um, algorithm that we've used here, but now this one is going to combine all of them, and then I get the prediction from each model. It's going to get the prediction from each model, and then it's going to incorporate user and movie biases, and also it's going to add it's going to do what is going to add weighted genre. Is it genre? Features. So the genre features, and also is going to ensure that the final prediction is within the valid range, the valid range. And then now this other function, this one is to create a set of user movie pairs from the test set, and also we define what um, a function to predict batch, because guys, if you want to like generate your data, like the prediction data. And I remember, I think the data set is around millions. I don't know. It's a big data. So if you will iterate the entire data set, it's going to take you forever, because it will try to go one by one until it finishes. So I tried to use here batches so that you can iterate with batches. And also remember, when you use like a large, like if you don't split in batches, then your system memory might have some issues, because it is going to use a lot of memory. But now if you split in batches, so it's going to consume like a few amount of memory. And also some computers are good, and other computers are not good. So basically, on that case, I wanted to like have a batch where it's going to do what, where it's going to check first of all like the initial memory. For example, if your computer with the batch size of 1000, if it will run well, then it's going to use that one. And then in the event like the batch size is a bit a bit like for example, if your memory is good, and then the batch size works well on this one, so it's going to try to check also on the other one. Remember, this function is going to utilize or to work on that, because here I have a for loop, and then I've initialized the start time. Then the get prediction here, I've listed the batch list that we have here. So it's going to try to iterate over it, and then it's going to like check on the batch size. So it's going to initialize with first of all 1000. That will be the time that's going to take on iterating the first batch. So if the time is good, then it's going to try another batch. So if the next batch, the time that it will take is more, if it's more, then it's going to maintain the first batch. That if it's not more, like the time will increase to iterate, or maybe to create prediction with this batch. Like if time is going to be less, Then again it's going to check on the other one. So only in the event the next batch will take a lot of time is when it will maintain the previous batch. So it's going to try to this. Remember, when the number of batch is going to increase, then the rate at which is going to do the is going to generate the prediction is going to increase. But also remember, when it increases, the memory also increases. Like it's going to use a lot of resources, data or a memory on your system. So that's why I tried to implement like it's going to iteratively check like the performance per batch. So this is what it's going to do here. And then once it's done, then it's going to generate the final prediction. It's going to generate here the final prediction, and this is going to generate like the top end prediction here. And then here is going to generate this function. This code here is to create like the submission data frame, and then it's going to create the submission data frame. And I remember here as it tries to generate the final prediction, it will display the progress. But I think, let me try to see this other one. Let me open this one so that I can show you what it does. All right, basically I think my okay, Jupyter. I want to show you what that package does. Okay. Let me try to open this one. I don't know. Yeah, let me see. Yeah, so it's going to display something like this. It's going to display something like this so that you can track the progress. You can track the progress. Remember, this first version is like the basic one. This one is going to take few time. You can see like this one took only around 38 38 minutes. But this one is going to take a lot of time because we are trying to tune uh, we are trying to tune like a hyperparameters for the models with this one that we are using here. We're trying to do it to perform here hyperparameter tuning. You can see. So this process is going to take some time here. It's going to take some time also because we're also doing the grid search. The grid search there. So it's going to take some time. So guys, basically this is in a nutshell what the code does. You can just download the notebook and generate the data set and submit, or you can decide to implement in your own way. But this is the approach that you are going to use. So guys, I thank you so much for following. Please make sure you subscribe. Kindly subscribe to support this channel so that it can grow. When it grows, it will reach also other people, and I think it might assist other people as well. But I remember this video is going to be unlisted for the ALX people alone. And once the project ends, I think I'll delete it so that I can use my own content to teach. So guys, thank you so much, and let's meet in the future.